Hi, my name is Arifa, and I'll be talking about the introduction. So first of all, what is stratigraphy? Stratigraphy is the branch of geology that is concerned with the order and relative position of strata and their relationship to the geological time scale. So among the subdisciplines of stratigraphy are lithostratigraphy, biostratigraphy, chronostratigraphy, and many more. So Kinta Valley is located in Perak, Malaysia, which is also known for its tin production. And this valley is formed by the Kinta River, as it is a tributary of the Sungai Perak and is bounded by two Triassic granitic bodies, which are the Main Range and Keledang Range. So in Kinta Valley, we see many karst features such as sinkholes, caves, and others. And the limestone of Kinta Valley is also a part of regional carbonate complex extending from Malaysia to China. The uniqueness of Kinta Valley lies mainly because its spectacular shape of steep sides, as we can see in Tambun, where there is a needle-like structure.
Assalamualaikum and hi, my name is Nur Awatif and I'll be talking on the deposition at the Keledang area, which is more related to the bedding, fracture and faulting at the area. Second hi, today we are at Kinta Valley Limestone. So as you can see, this part is a depositional area of carbonate limestone. Actually, it is very rare for carbonate limestone to be deposited in a bedding manner, and this bedding actually formed during the Triassic to late Jurassic area. And as you can see, at the bedding there we can see the pinkish part, which is like the ionized dolomitous limestone that contains iron. And if you go up there, you can see the red part there is called raw. It is actually iron salt. At the field, we can identify that there are three sets of fracture there, which is the vertical, the inclined, and the horizontal one. And at the faulting, we can see that the fault there, the fracture there are actually silted. This happened due to the genesis process that occur at the carbonate rocks. And the next is I want to talk about the secondary carbonate that we have found there at the outcrop. The secondary carbonate there is actually a concretion. Concretion is a hard and compact matter that is happened due to the precipitation of mineral. And concretion there was surrounded by clast that is deposited in a non-marine area. And the position at non-marine area is very crucial because it indicates the paleoclimate there, and different layers of the rock will actually indicate the different climate that occur back in the Paleozoic area, Paleozoic age. And the next is I want to talk on the fracture that occur in the cave at Keledang, which is related to the stalactite formation. So for the stalactite formation, it is actually occur because there is a fracture at the top of the cave. So when water drips from the fracture, it is somehow have a chemical reaction with the carbonate rocks and will drips that it is and will eventually be exposed to the carbon dioxide and will gradually become solid as the dripping process occurs. And that is how the stalactite process happened in Keledang.
Hi, my name is Amira Nadia, and I'm going to be talking about the chronostratigraphy of the Kinta Valley. So the Kinta Valley that we see at the present is basically the result of the geological processes that happens around 400 million years ago, or maybe even earlier. The Kinta Valley comprises of mainly Paleozoic limestone formation that are bounded by the granitic ridges. The Kinta limestone is one of the massive carbonate deposits which has longer temporal extension from the Silurian to Permian and spatially cover the central part of the western bed of the Peninsula Malaysia. The original limestone bed was presumed to be around Carboniferous to possibly Permian in age that has been eroded or karstified. The Paleozoic Kinta Valley limestone overlies the younger late Triassic to early Jurassic granitic bodies, which has affected the texture and also the composition of the limestone and shale through the contact metamorphism. So over the processes of million years, the Paleozoic limestone of Kinta Valley form of what we call as the tower karst. So tower karst is basically the hills which is a remnant of thick limestone sequence dissolved through the process of karst. So some studies on the structural history of the Kinta Valley has been done, and based on the assumption on the relative chronology of the lithology from the oldest to the youngest, and it's said to be first interbedded sandstone and mudstone, shale, limestone, granite and alluvium tailing sand. The geology history of Kinta Valley is composed of two parts, the deposition and also the structural deformation. The deposition begin with the deposition of sandstone, alternating with mudstone, and eventually form the interbedded bedrock during the Devonian period. And following this was deposition of the fine grain shale lamination, which have high carbon content during the Carboniferous period, which is expected around 360 million years ago to 290 million years ago. Permian limestone was deposited after the shale from 290 million years ago to 250 million years ago. The granite intrusion occurred after the limestone during the late Triassic to early Jurassic, which is around 230 million years ago to 193 million years ago. And finally, the younger quaternary alluvial sediment were deposited and overlays the existing rock.
My name is Akil Ben Anas and I will be talking about lithologies around area of Kinta Valley. Okay, there are 5 major lithologies in Kinta Valley, which is the first one being the oldest one being granite, the second is interbedded sandstone and mudstone, the third one being shale, fourth being limestone, and the fifth being alluvium. Okay, these lithologies has been there around the late Devonian until the Quaternary. Okay, the 4 major lithologies, which is the sandstone, interbedded limestone and mudstone, interbedded sandstone and mudstone, shale and limestone has been there since Devonian until late Jurassic. But then the most recent one, which is alluvium, has been there since Quaternary, which is 2.5 million years ago.
Hi, my name is Ratu. So today I'm going to explain about the biostratigraphy and summarize everything. So for the biostratigraphy, as all of us know, conodon is one of the fossil that is found in Kinta Valley. So to date, high resolution conodon biostratigraphy of Peninsula Malaysia has focused mainly on the south-northwestern part of the Western Stratigraphic Belt, as this part of the peninsula commonly contains an almost complete stratigraphic succession of Paleozoic strata, which is relatively fossiliferous, less affected by metamorphism. And conversely, the current biostratigraphy of the Kinta limestone, which is the main carbonate lithological unit found within the Kinta Valley. In this central part of the Western Belt, it is based solely on some poorly preserved uncommon microfossils recovered from the outcrop samples within high metamorphosed sections. So there are workers on biostratigraphic studies in Kinta Valley, such as Gobert, that found foraminifera, and Suntara Lingam, who found mollusks and tabulate corals from thin mine outcrops, and they determine the age of the succession as the Middle Devonian to Middle Permian. So to summarize everything, we have talked about deposition, chronostratigraphy, lithology, and biostratigraphy. So, as number of isolated Paleozoic, limestone hills with prominent karstic features cover an area about 200 km squared within the 1,200 km squared area, 1,200 km squared area in the Kinta Valley in Peninsular Malaysia. These are remnants of extensive limestone beds, which are part of a very large Paleozoic carbonate complex that cover large parts of Southeast Asia. The limestone beds are interbedded with sandstone, siltstone, and carbonaceous shale over a thickness of 300 meter. 3,000 meter. The Paleozoic Kinta Valley limestone overlies younger Triassic granite bodies which had affected the texture and composition of the limestone and shale through the metamorphism contact. In spite of these sedimentary structures, such as delaminations, lumps, and meter-thick beds of brachiated shallow marine, fragments are still clearly visible in some places. This indicates that the Paleozoic limestone of the Kinta Valley was deposited on a slope. The strut-ended direction of the slump indicate the presence of north-south oriented shallow marine platform margin to the east of the Kinta Valley, prograding towards central peninsular Malaysia. Outcrops in eastern peninsular Malaysia confirm the presence of a shallow marine platform with potential reservoir horizons that probably extended eastwards far in the South China Sea. That's all from me. Thank you.